Hello friends, welcome to this YouTube channel. Today we shall learn how to verify Kirchhoff's voltage law experimentally. We shall learn which instruments are to be used to perform this experiment, how to choose proper range of instruments, and how to connect them to conduct this experiment. We shall also learn which experimental observations are to be noted, how to tabulate them, how to calculate error, and finally how to come to a conclusion. Verification of Kirchhoff's voltage law. The objective of this experiment is to verify Kirchhoff's voltage law. Let us have a look at the statement of this law. It states that at any instant the algebraic sum of voltages around a closed loop or circuit is 0. For a closed loop having k elements, summation of Vj equals to 0, where j equals to 1 to k. Let us construct a closed loop using a DC source Vs and two resistors R1 and R2. Let the loop current be I. Let the voltage drops across R1 and R2 due to flow of current I be V1 and V2 respectively. According to Kirchhoff's voltage law, V1 plus V2 minus Vs equals to 0. Or we can write V1 plus V2 equals to Vs. Let us verify this expression experimentally. This experiment may be performed on a trainer kit, but we shall learn how to conduct this experiment using discrete components. We shall need a variable DC source to supply our circuit, voltmeters to measure the voltage drops. The PMMC type instruments will be preferred because the circuit supply is DC. A couple of rheostats will be required to construct the circuit. We can use multimeter instead of voltmeter to measure the voltage drops. Let us first theoretically compute the voltage drops across the circuit elements. This will help us to choose instruments with proper ranges. For this purpose, we shall take two resistors R1 and R2 and a variable DC source Vs to form a loop. Let R1 be 15 ohm, R2 be 25 ohm and Vs be 20 volts. This circuit comprises of one loop. Let the loop current be I. Applying Ohm's law, we get I equals to Vs divided by R1 plus R2, that is equal to 20 divided by 15 plus 25, that gives us 0.5 ampere. Let us now compute voltage drop across R1. V1 equals to I into R1, that is equal to 0.5 into 15, that gives us 7.5 volts. Voltage drop across R2, V2 equals to I into R2, that is equal to 0.5 into 25, that gives us 12.5 volts. Let us now tabulate voltage drops Vs, V1 and V2. When Vs equals to 20 volts, we have found V1 equals to 7.5 volts, V2 equals to 12.5 volts. If we increase Vs to 40 volts, V1 equals to 15 volts and V2 equals to 25 volts. If we further increase Vs to 60 volts, V1 equals to 22.5 volts and V2 equals to 37.5 volts. From this table, we observe that to measure the supply voltage, a double range voltmeter is to be used. When supply voltage is below 50 volt, we shall use 0 to 50 volt range, and when supply voltage is more than 50 volts, we shall use 0 to 100 volt range. To measure V1 and V2, we can use voltmeters with 0 to 50 volt range. Let us now construct the circuit required to verify Kirchhoff's voltage law. For this purpose, we shall take a variable DC source Vs and two rheostats R1 and R2 and connect them using flexible wires to form a closed loop. Now we shall connect one PMMC type voltmeter across Vs to measure the supplied voltage. This is of 0 to 50 volt to 100 volt range. First we shall use 0 to 50 volt range, later we shall reconnect to 0 to 100 volt range. Now we shall connect two PMMC type voltmeters across R1 and R2 to measure voltage drops V1 and V2. Let us now form a table to tabulate Vs, V1 and V2. Here we shall take 3 sets of readings, but while doing the experiment in the laboratory, we must take at least 5 sets of readings. Now let us turn on the supply and set the supply voltage Vs to 20 volt. Now we observe V1 equals to 7.5 volt and V2 equals to 12.5 volt. Let us increase the supply voltage Vs to 40 volt. Now we find V1 equals to 15 volt and V2 equals to 25 volt. Now we shall change the voltmeter range to 100 volt. Now we shall set the supply voltage Vs to 60 volt and we observe V1 equals to 22.5 volt and V2 equals to 37.5 volt. We have already tabulated Vs, V1 and V2. When Vs was 20 volt, V1 7.5 volt and V2 12.5 volt. When Vs was 40 volt, V1 15 volt, V2 25 volt. When Vs was 60 volt, we have obtained V1 equals to 22.5 volt and V2 equals to 37.5 volt. Let us now prepare the final table. As we have taken 3 sets of readings, serial number will be 1, 2, 3. Let us now put the values of Vs in this table: 20, 40, 60. Now let us put the values of V1: 7.5, 15, 22.5. Now let us put the values of V2: 12.5, 25, 37.5. Now let us determine the algebraic sum of voltage drops, that is Vs dash equals to V1 plus V2. For the first set of reading, we get 7.5 plus 12.5, that is equal to 20 volt. For the second set of reading, we get 15 plus 25, that is equal to 40 volts. For the third set of reading, we get 22.5 plus 37.5 equals to 60 volts. Here we find that the values of Vs and Vs dash are equal because this is a hypothetical case. While doing the experiment in the laboratory, we shall observe that these values will differ, though by a very small amount. Now let us calculate the error. Vs minus Vs dash divided by Vs into 100. For this case, error will be 0 in each case because Vs equals to Vs dash. But in reality, we shall find a very small value of error. So now we can conclude that the Kirchhoff's voltage law is verified. Let us now prepare a list of equipments used to conduct this experiment. This table should not only include the name of the instruments but also their specification, maker's name and maker's number. We have used a variable DC source to supply power to the circuit, 3 voltmeters to measure supply voltage and voltage drops across the rheostats, 2 rheostats to form the circuit. Maximum applicable voltage was 60 volt and maximum supply current was 1.5 ampere. Therefore, we can use a DC source of 0 to 100 volt, 5 ampere rating. We have used PMMC type voltmeters, one having dual range of 0 to 50 volt to 100 volt to measure the supply voltage. When supply voltage was below 50 volt, we have used 0 to 50 volt range, and for higher value of supply voltage, we have used 0 to 100 volt range. To measure the voltage drops, we have used PMMC type voltmeters having 0 to 50 volt range. We have used wire-wound rheostats, one having 20 ohm 5 ampere rating and other having 50 ohm 5 ampere rating. If we use multimeter to measure voltage drops instead of voltmeters, then it is to be included in this table. So today we have learned how to verify Kirchhoff's voltage law in the laboratory. We have learned which instruments are to be used to perform this experiment, how to choose proper range of instruments, and how to connect them to conduct this experiment. We have also learned which experimental observations are to be noted, how to tabulate them, how to calculate error, and finally we have learned how to prepare the list of equipments used. Hope this lecture has been useful for you. If you have any suggestion or question, please drop it in the comment section below. If you have liked this video, give it a thumbs up and share it with your friends. Thank you.